Hey everybody, so welcome to my talk about why we should care about code splitting. I gave the talk like half a year ago at ViennaJS, but it was kind of like a prototype of it. So hands up, who has heard about, who was here like half a year ago? I see one hand, two, okay. So not too many, so it's good.
That's good, it would be awkward if 90%.
Yeah, then it would stop and go home. So yeah, my name is Glenn Reyes, and for the one behind, this is my face, if you see it. And this is also my Twitter handle, which is my name actually, but without the E's. And I'm a freelance front-end engineer, currently working with React and currently working with GraphQL. And I'm also married, I play the guitar and like to be around the globe. So I'm also part of the React Vienna meetup group, which is, I help them up to organize meetups, and the next one is on December 13th, so you may want to check this out if you're interested in React or React related stuff. And yeah, let's talk about a little bit code splitting. So hands up in the air, who knows what code splitting is? Awesome. Who knows, who has played with it but haven't had the chance to ship something with it? Who has shipped production app with it? Not too many. Oh, that's... So what is code splitting actually? Code splitting is nothing but a feature that allows you to split code into, that can be loaded on demand or in parallel. So what does this mean in our component architecture, like in React? So let's say we have this component tree, and the top level one represents like the entry point, imagine of Webpack, the entry point of a module, and that imports React components and so on and so forth. So most apps likely have routes to separate the views, right? So let's say this part in the blue are the components that is used for the home route, and the one on the right is are the parts that are used for the profile route, right? So this example just uses 2 routes in total. And most simple configuration of a bundler like Webpack, for example, they generate like one giant bundle, and it contains like npm packages and all the React components. They all are squeezed into one giant monolithic bundle that can be really big depending on your application. And the problem is if you would only visit the home page, for example, all the parts that you use for the profile page would be loaded as well over the network. And so we need to split the bundle into smaller pieces. And to do so, we first want to define splitting points exactly there and separate pieces of code. So we want to basically set boundaries that are specific to the views, and our share code that is used across all pages, which is in this case only the entry point. And as a result, we expect to have our application divided into separate smaller pieces of chunks. And it's in this case we have the bundle.js and the parts for the home.js and the parts for profile.js. These 2 parts are like the route-specific chunks that you would use only if you visit this route, right? And imagining visiting our app, if you visit the home route, these are the parts that you want to load over the network, right? And all the pink parts shouldn't be loaded as you visit only the home page. And yeah, again, these are the 2 bundles that you want to load that should be present when you visit the home page. So we want to skip the profile code because it's not needed at the moment. And because of this, we will potentially improve performance and reduce page speed load, right? And actually, why should we care? Do we really need it? And when I started to dig deeper into this, I was like, hell of God, I don't want it. It's just probably too much overhead. My app is too small enough. I don't need it, right? And of course, if it was just me, I wouldn't need it because I'm really spoiled, and most of the time when I'm surfing over the internet, it's on 100 megabytes per second, and all of us here, we know it. We are all engineers, and we know how to handle networks, and to get like fast internet connection. And we know that we are privileged. So, and most of the time, we know how to troubleshoot tech, right? And we should really appreciate it. So mostly, we don't have to worry about properly accessing our web apps. And it's basically everything is cool until we see this guy, right? So everybody hates this, like, especially if you need something immediately, but you need to wait like forever, and it's really frustrating when, especially in situations where you need connectivity right now. Imagine you're in the middle of nowhere, right? And then your only survivor is now internet connection, and then suddenly you see this guy, right? So the thing is, we are used to expect the internet to just work, and in fact, the vast majority of people surfing on the internet right now is not on our giant, super high fast computers. It's like this. More and more people are using the internet over the smartphones and very little phones that are very that does not have the same capabilities like our computers, right? So again, back to the question: why should we care? Code splitting can help out to reduce our idle time, and despite this, why we want to code split is because it's so simple. Code splitting is nothing else but replacing one line of code with 4 lines of code. It doesn't mean you need to refactor like your whole application or half the code of the application. It's basically three more lines of extra code. Now, how does code splitting mean for performance? How does it increase performance? So one reason why I want to code split is to separate the bundles is long-term caching. And long-term caching means you split your vendor code, like packages in node modules, that almost never changes, with app code that you frequently update and add features over the time. So, and after this, you basically get the benefit of not re-downloading npm packages that hasn't changed deployed after you have deployed your app, right? And also, split up codes are being loaded asynchronously by using the power of promises. And this means you don't have to worry about render blocking while you're loading the page. And this allows you to easily customize components like loading components and render them as you want, and they're already there as you want them to be rendered, right? So with code splitting, all necessary code are loaded on demand, and the bundler will take care of injecting code automatically to the DOM, and that is needed in the page. I'll explain it a little bit later. So we as developer, we shouldn't have to worry about what happens at the low level, the DOM level, right? So what we aim for is not to waste any kilobytes that's being downloaded through the network, and what we aim for is to load code as needed. So yeah, you might be curious about how this works, and let's take the app example earlier, where we have this our home route, right, with the blue background. And if we take a closer look to the HTML element tree, we see that we have here underneath the bundle.js, which is our shared application code, and here in the head, the home.chunk.js that is loaded as our app recognized, oh, we're here at the home page, and so let's load this dynamically. And after both scripts are there, you will see your app in the end rendered on the browser or any environment. So as we click on the profile page while being on the home page, and looking at the dependence, looking at the HTML element tree again, we notice there's now another script tag, which is the profile.chunk.js. And the profile.chunk.js is the part that we have that is used for the other route. And we notice we have now home.chunk.js, profile.chunk.js, and bundle.js. And the thing is, we moved from the home page to the profile page. And as we moved to the home to the profile page, we dynamically loaded another chunk. And the code that we have in the profile page is dynamically been added to our browser, right? So everything is there, and nothing will be loaded anymore through the wire while we have this. And if you're using CSS in JS, all styles are being downloaded dynamically for free by using this code splitting, because CSS in JS relies on your modules and relies on your components that you're using. They are all tightly coupled on them, and because of this, styles are loaded on demand as well, which is really powerful actually. And despite this all, we can also load code that is dynamically based on interactions, and yeah, it's really cool, isn't it? So yeah, let's take a little bit of a look at the syntax. So right now, there are a number of ways on how you want to import modules or components into some modules, right? So there is, for example, a system that this is really bad to read, but that's system.js, system.js.import, for example, or system.import, which is, I think, Webpack 2 or so. And there's also CommonJS requires and require.ensure. And even people implemented their own way of importing modules. And there's thankfully something better than this. And it's called dynamic import. So it looks like this, and it's really awesome and very familiar for us JavaScript developers. So what is it, and how do I use it? Syntactically, it looks like a function and uses the reserved word import as the name of a function. But yeah, it accepts the path to your module, and it doesn't actually behave like a function. It behaves more like the super in your constructor, for example. It doesn't. What it also does is it returns a promise and behaves like this. So a lot of open source libraries are adapting this feature because the syntax makes a lot of sense. And there is an open TC39 proposal which you can check out at GitHub. And if you're interested into the steps, I think it's currently in stage 3 right now, but if you're interested into the progress, so definitely check this out. But even if it's a proposal, we don't have to wait for this to land to the spec, right? Because with Babel, we're able to use this syntax today, and with the syntax dynamic plugin. And with this, Babel will be able to parse the new syntax, the new import syntax into code that is actually readable in your browser or any other target environment. And actually, I want to add to this is Chrome beta and Firefox beta, I guess. They have it already in the browser natively. So they implemented it already into the browser. But yeah, if you're still using other browsers than the beta, so the magic will happen all in the bundler, which is in this case Webpack. And you find here fantastic guides on how to set up code splitting, what it does, and all the information you need for setting up and configuring this thing. And also there is a nice step-by-step guide from Juho of survivejs.com. So definitely check this out. It's a really great thing. I also tweet my slides so you don't need to catch pictures or. So now let's talk a little bit more about how dynamic imports are different to synchronous imports. Basically, ES6 imports loads modules synchronously by just importing import chart from chart and so on, and then you have access on the module. So it's nothing new, right? And with asynchronous imports, using dynamic imports, you basically call the import by passing the path of the module, and then use it just as you would do with promises, like in this case with the .dan module, and then you have access to your module. And the cool thing is you can use async and await with import as well, with dynamic import as well. You just basically wrap an async at the wrapping function, or add an async to the wrapping function, and then you can access to the module with prepending await before your dynamic import. And everything looks more like imperatively and more like sync code, even if it's async code, right? And let's talk a little bit about more how you would use dynamic imports with React. And note that React isn't just the only way on how you can apply dynamic imports. There's a lot of frameworks like Angular, Vue, or Ember that probably will adapt this feature too, right? So, but for now, I'll show you an example in React. So in our app component, we basically want to render a component that is being loaded asynchronously, or we basically want to load an asynchronous component by importing something, and once the app has been mounted. So what we want is we want to set an initial state in our React state, and render first or return first with a function simple React element to just show that nothing has loaded. So this is our synchronous nothing has been loaded indicator, right? So, and React components has this pattern that is called lifecycle hooks, like component did mount in this case, and it fires when the component has been mounted. And in component did mount, we want to call the dynamic import and pass the path to the async component as an argument, and then we simply assign the result to our constant async component, and then we simply set the state to update or to perform a re-render of our component. And with setting the state, we basically replace that we have in this nothing loaded indicator with our async loaded component, right? So, and in the render function, we will first see the nothing has loaded indicator, and after the async component has been loaded, it will be loaded afterwards, like after the set state has been called, and after the app component has been re-rendered, right? So, but what about loading multiple components at once? And for this, we can take advantage of promise.all, and it's basically just the same thing like you would do with simple promises. And in component did mount, we basically would call the promise.all and then pass an array of dynamic imports, and then we set the state of components, which is here an array, and initially an empty array, and after we have set it, it's an array of promises, and then in render we simply map through the array and then render them, right? And you probably might be like, are you kidding me? This is not 3 lines of extra code. This is actually you screwed my component. So what's going on here, right? And for this we have React Loadable, which will be able to cut these lines down into just a few lines. And it's a higher order component authored by James Kyle, and it's basically taking all the complexity that I just showed you before and makes dynamic imports makes using dynamic imports even easier. So including server-side render support. Here's a tiny comparison of a synchronous route, and here we simply pass the component with the component prop, and if we want to do it asynchronously, we basically call the loadable higher order component and pass a bunch of options, like here in this case loader, with a function that returns the dynamic import, and here a loading indicator, which is also again a simple React element. And what this would do is the example that I've shown before. but only in 3 lines, right? And with this, we will be able to, replacing this with this, we will be able to make our app up to 5 times faster than before. And Create React App is a great way to start using dynamic imports. It supports this, and also you'll be able to do this with React Loadable. It's 100% compatible with this, and especially if you're new to React, it's a great way to start, actually. So definitely worth consider using it if you start new projects. Or some of you might be like, Create React App is not an option, and we need server-side rendering for our app, right? And of course, there must be something. And there's Resl. Resl has some parts of Create React App, but also does the parts on the server too. So it has like 2 Webpack instances. And I played with React Loadable and made experiments with this. So check this out. This is basically Resl with React Loadable and has server-side rendering support with it, and just works like Create React App. And also there's Next.js, which has code splitting and dynamic imports out of the box. It has a very minimalistic API and renders your app completely on the server too. And I guess agent.sh uses it, right? So yeah, check this out. Guillaume Rauch, author of Next.js, mentioned that Sci.co is built of it and uses hundreds of code splitting entry points. And with this, they have reduced boot up time from 1,000 milliseconds to down to 200 milliseconds, which is pretty awesome. So when I started to dig deeper into this topic, I saw so many guides on how to do and what it does. But in reality, where I was more interested in was how do I actually make it right? How does the big player do it? What are the common practices, and how do I actually make my app even faster? And I'd love to share an approach that works for me of applying common practices and to strategically code split the entire application. And the first, besides dynamic imports, you may want to split your code, your app code and vendor code that I've explained before, to get the benefit of long-term caching, as I've mentioned before, to create one bundle for the vendors and another bundle for our frequently updating app. And if you want to read more about this, here is a nice Medium blog post by Tim Sebastian, and he basically treats the problem with named chunks and named chunks IDs. So check this out. Yeah, the second is consider code splitting your code at route level using dynamic imports. This is basically what I've showed you the last 15 minutes. Every single line of code of a page that you visit that typically belongs to a page, right? So in general, it's common practice to split your code at the route entry points, and even there might be code that can be shared. So if you have the case that you have like shared code between routes, even for this, Webpack has an awesome feature which is called Webpack chunk names, and it's basically doing this import thing and then adding this weird comment in between. And with this, you'll be able to organize and group multiple chunks of modules together and assign it with the same name. And it's pretty neat, especially if you want to use shared code just for parts of the app, right? And the third thing is, after splitting vendor code with your app code and then further down, splitting your code at the route level, consider splitting your code further down at component level. So what does this mean? Imagine you have this huge chart, but imagine it's still not in this view. Imagine it is somewhere not in the view, not in the viewport. And what you want is to load this chart as you scroll in. So you might want to lazily load this chart into the view, and it's really important to do this, especially for bigger components, for example, like charts so you don't wastefully load something to the browser, or you will be able to render things faster to the viewport by splitting them up component level. So also we shouldn't overuse dynamic splitting points, since this can also have a negative effect. So don't split everything, but don't split definitely like big things that are like where you feel you want to split them, right? So also try to predict what the user intends to do in your app and prefetch based on your user interaction. So sometimes there are use cases where users most likely will click on certain things, and therefore you can prefetch the chunks so that the code that is already there and prepared for the user to be displayed. And React Parameter is actually a great tool for this. That can be used for prefetching data based on mouse behavior. And with this, you can define, for example, like imagine you have a component, and then you add, then you have like a parameter, like an area where your mouse breach in, and then you load everything for the next route, for example, by calling a function. So it looks like this. Imagine your mouse is here, and then as you move here, you load now the chunks that you're about to visit to the next route, for example, and then it's loaded, and it's loaded before you click on the button, right? And this is how the syntax would look like, and it's very simple. You have here the parameter element, and here the button as a child, and here in the onBreach you basically define your intent when you click, or when you breach the gray area that I've shown you before. And this is actually the padding that can be set with React Parameter. So it's a great thing to do prefetching as well. So to sum up, we were code split app and vendor code for long-term caching, split at route level asynchronously to load only the code that is needed for the page, and also split at component level to lazily load parts of the page as the user scrolls in or as the user interacts. These are the nice good reads. If you're interested in code splitting benchmarks and loading performance, definitely check them out. And to recap, dynamic imports, it's a TC39 proposal with Babel. You can use it now. Don't load useless code by splitting your codes with dynamic imports. Depending on the project size, we'll be able to reduce the page load up to 5 times. First, split app and vendor code, and then at route level, then at component level. Create React app and Next.js are cool ways to start. Also check out this RESL experiment that I've shown you before. And also note that the idea can be applied to any framework. It's not just React. So yeah, that's basically it. If you're interested to talk more about code splitting, definitely talk to me. And yeah, also you can ping me on Twitter if you want. So thanks very much. That's it.